Good morning, good afternoon, and good evening. This is a presentation on the C.U.T.E domain-specific did grammar for did document collections. In addition, we'll be describing how the $supported capabilities transformer option might be implemented. My name is Michael Herman, and I'm an independent blockchain architect, and I live on a cattle ranch in southern Alberta. The purpose of this presentation is to document the C.U.T.E domain-specific did grammar for did document collections. Previous webcasts have talked about the did grammar for did documents, the domain-specific did grammar for did documents. This is specifically around did document collections. And now that we have sort of three different examples, this will help us understand how best to implement the $supported capabilities transformer option. The primary or intended audience for this presentation is implementers and maintainers of PARSER software that is compliant with the did-uri-spec, including but not limited to projects or application domains that use W3C Decentralized Identifiers, the did resolution spec and people developing did resolvers, and also the many applications within the agent-to-agent communications framework on the Hyperledger Indy platform. What is a C.U.T.E did grammar? A C.U.T.E did grammar is a did-uri-spec compliant grammar that is concise, understandable, and technically elegant. A C.U.T.E did grammar is a did-uri-spec grammar that is easy to extend to target an infinite number of application areas or domains by making it really easy to create domain-specific did grammars, and of course then to automatically generate compliant parsers in Java, C++, and C#. A DSDG limits the number of transformer options that are required or available for a specific application domain. The baseline or generic did grammar, as well as any DSDGs derived from the C.U.T.E did grammar, are verifiably did-uri-spec compliant and in turn RFC 3986 compliant. As discussed in all the previous did-uri-spec webcasts, a very specific approach called principles-based architecture and design have been used. I'm not going to go over these articles again, but again, what we're seeing with domain-specific did grammars is sort of a very pure application of these concepts. So here, just reminding ourselves what the C.U.T.E did grammar looks like, aka the did-uri-spec grammar, the generic grammar, the baseline grammar. Those are all equivalent terms. We see the did-uri rule in the second paragraph of rules there. It's a did followed by a transform, followed by an optional path, followed by an optional query, followed by an optional fragment. And that a transform itself is can be multiple transformers following the pipe symbol and separated individually using the ampersand. And we're going to see this construct used significantly when we look at how do we want to process, or how do we want to, what is the mechanism for describing what subset of a did document collection we want to have returned. In the generic grammar, we see the transformer options listed at the bottom is just one. It's the generic option, which is a alphabetic character, an identifier that starts with an alphabetic character and is followed by any number of additional characters. This will match any compliant did-uri-spec grammar. It's RFC 3986 compliant. And we're going to show how we take this generic or baseline grammar and extend it to a domain-specific did grammar for did document collections. So here's the famous slide 45. So here we're looking at these bottom three did use cases, did URI use cases. 9A is it's pipe $documents applied at the did level, or the same construct, pipe $documents piped or applied to a did method, in this case did :XYZ:. And there's going to have to be some defaults around that, for example, limiting the number of documents returned, let's say, to 10. If we look at 9B, here we're taking more specific control over which documents and how many documents are returned. So again, we're still using pipe $documents, applying it to a did method, did :XYZ:, but we're only asking for 10 did documents to be returned, and that we're going to skip the first 100 documents that the resolver would return to us. So to restate that, it's skip the first 100 documents in the did :XYZ:, did method that are available from a particular resolver, and return the top 10. So it's a batching process. 9C is a slight elaboration on that. We're still essentially doing a similar kind of selection, but we've added the $filter transformer option. We've seen that before applied to attachments in the agent protocol discovery scenario. But here we're saying of all the documents that are available for the did :XYZ:, did method on a particular did resolver, apply a filter and only return those that have a service endpoint, and of those that are returned, skip the first 100 and return the top 10. Here's slide 46. On slide 46, we really only have one of the did-uri use cases that's in scope, and that's testing for the existence of a particular did, a particular fully qualified did. But of note is the $type transformer option. These are not in scope because the scope of this particular grammar is limited to did documents. But you could imagine another version of this grammar that is scoped to all of the documents, for example, available on the Indy ledger. So in that case, we would add $type to the list of transformer options. But by default, implicit default, the $type is set to did document for the use case that we're looking at. And here we see the domain-specific did grammar for did document collections. It's only showing the bottom half of the grammar because the top is always the same. And we can see in the transformer option section, we have the list of available options, and you can have any, almost any composition of these options would make some sort of sense. The actual meaning applied to those would be post parser in the semantic analyzer, going back to the original did-uri-spec webcast. But the options for did document collections. For the did document collection, domain specific did grammar is documents, filter, skip, top, select, exists, and then for now we're including the generic option. But again, if you wanted a tight grammar, you could remove the generic option. So the documents option would be required for this particular DSDG, and we'd catch that in the semantic analyzer. And it says that I want some collections, some set of did documents returned from the did resolver. Exists is mutually exclusive with documents, and it asks, does a particular did document associated with a particular did exist? So that's quite a different use case. When you use the documents option, you can apply any one of the bottom four transformer options inspired by the OASIS ISO open data specification. And you can see the URL there. So there's filter, skip, top, and select. And we'll see examples of those in a minute. So we've just seen the domain-specific did grammar for did document collections. And here, here's just a reminder of the constructions that are supported by that. So then $documents by itself as a single transformer option, or you can see the compositions in the user scenarios 9B and 9C. 9B is again 9B and 9C both use the pipe $documents. That's how you get a subset of documents. In this case, we're scoped to did documents in did document collections. So it's by like defaulting the $type to be did document. But in 9B, we're saying skip the first 100 documents that are available for this particular did method, and take or return the top 10. And then you could do skip 110 and give me the next top 10, and skip 120 and give me the next top 10. So there's a pattern there. But this is a URI that specifies what is to be returned. 9C uses the filter transformer option to pre-filter the list of potential documents to only those that have service endpoints, skip the first 100, and return the top 10. The reason for the pause or the hesitation there is I'm trying to word these descriptions so they don't sound prescriptive or procedural. This is describing what is to be returned, and by definition, that's an RFC 3986 compliant URI. So in all the previous did-uri spec related webcasts, I've intimated that at a did method level, there is a transformer called supportedCapabilities that would return a document representing the array of capabilities supported by a particular did method. But to be honest, it wasn't clear what it was that would return. What's becoming more and more clear through the invention of these domain-specific did grammars is the list of supported capabilities is in fact the transformer options that are available in a specific domain specific grammar. And so while the jury is still out, I'm thinking that $supported capabilities could indicate or could return an array of named grammars. or perhaps, and I think that's the right answer, or it could be an array of transformer options that are supported. But we'll see how that goes. But it's for those people that were concerned about, again, the diversity of functionality and capability in the parser. Again, the parser should be open. It should be open to innovation. It should subscribe to the open to innovation principle. But a particular application developer does need to be able to understand what capabilities does a particular did resolver support for a particular did method. And it's starting to look like, again, Darler supported capabilities could return an array of a list of machine readable domain specific did grammars. We'll elaborate that one more on that in the futures as implementations prove themselves out. Just a reminder that once you have these grammars, you can automatically generate the parsers. This is a great tool here. Parse2.com website has the parse. From a grammar testing and validation perspective, we have the BNF Parser 2 website. We'll also be generating, using the parser tool, a similar validation tool. So wrapping up, we have this ability to derive domain-specific did grammars. So we start with the generic or baseline did-uri-spec grammar. In previous webcasts, we've shown how we can generate a domain-specific did grammar for did docs. And now we've shown how we can generate a domain-specific did grammar for did document collections. Taking this step further, this also suggests there's the possibility for doing domain-specific did grammar composition. That is, if you need the functionality for a particular application domain, for a particular app that you're building, if you need to work with collections of documents, did documents, and then, of course, being able to parse individual documents or individual dids within those documents. And that's an important clarification. The did-uri-spec grammar and the parsers you generate from that, they're for parsing dids and did-uris, and they're not for parsing did documents. So I needed to correct myself there again. But coming back to the idea of composition, if you need both sets of capabilities, then you can easily take the transformer options from did docs, combine it with the list of transformer options for did dot collections, and you have a grammar then that will support parsing and doing semantic analysis on the did URIs that appear at both levels. So the next steps are the same as before: continue and grow the number of higher level scenarios, work with diverse did communities, investigate diverse higher level use cases, particularly within the collection of Indy hypes, IPID, and other projects. Begin formal testing of the DSDGs, and continue the outreach in terms of awareness, knowledge, and understanding with all did communities. If you have any questions, feel free to contact me directly at mwherman@parallelspace.net. I will return and answer every question. I also hang out in the Hyperledger Rocket Chat. forums, or if you're watching this YouTube video, you can post a question in the comments section of the YouTube video. Thank you for watching this 20-minute webcast. I appreciate your time and your interest, and I look forward to understanding how the did-uri-spec can help you, and in particular how this concept of domain-specific did grammars can assist your project.